Hey everybody, this is Larry. This is me doing day 15 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Today's problem. Come to Discord, yay. Largest divisible subset, 368. So you're given a set of this thing, return large subset every pair. Okay. So you have to give the answer. Okay. So I think this one's a little bit tricky, a little bit mathematical, or maybe a lot mathematical, depending on who you ask. I think the first thing I would say is that every number should probably be able to be represented, or every solution should be able to be represented by the largest number, because let's say we have 1, and then you go to 2, and then you go to 4, and then you go to 12. Here, in order to add 12, we know that if there's I guess there's this thing where, okay, let's say we consider adding a new number 12, right? Well, 12 mods 4, so we know that's good, but that means that by implication that because we have 12 mods some number that 4 mods some smaller number is equal to 0, so that means that roughly speaking, every number smaller than 4 in this set will be 0, right? So then it becomes, I guess, a sort of a breadth first search longest path type thing, because essentially if you sort it and you have a DAG and you're able to kind of and it becomes the longest longest path in a DAG, which you can solve with dynamic programming. I mean, you can maybe even do breadth first search. I think it's fine, but yeah, I think that's mostly where my logic is at. And the idea is that because there's this what's it called, inductive type thinking that I don't know if I can explain very well, because it's really number theory things, and I'm not very good at those, to be honest, especially explaining them. But you can think like, yeah, I mean, there could be multiple paths, right? For example, so this can go to 612, but you just take the longest one, and then 12 will be represented. I think that should be okay. Yeah. And again, this is, of course, if you kind of, after you sort it, you can think about this as the longest DAG in longest path in a DAG, which is of course a very standard dynamic programming problem. So I think that should be the answer to it. Let me give it a go. Let me give it a spin. I am solving this live, so if I do make a mistake and that happens to not be true, we'll see. But of course, that's going to be n squared because of how we write it. And given the n is 1,000, I think we should be okay. So let's give it a go. Right. So first, I'm going to, just for teaching purposes, I'm going to write this in return a number kind of way, and then we'll do path reconstruction to get the actual answer. You don't have to do it this way. There are a couple of ways you could have done this, but I'm going to do it this way so that I can maybe teach a little bit path compression. Oh, sorry, path reconstruction. So yeah, so then here we have, so let's say the best answer is equal to, let's just say 1 times n, because you always have just one number. So yeah, so that's why my base answer is 1. So for I is in range of n, for j is in range of let's go from 0 to I, right? And then this is basically I have to sort first. I forgot to sort, because once you sort, only one of this can be true, which is that j is bigger than I, right? Or num sub j is bigger than num sub I. So then now we can do something like, if num sub I num sub j is equal to 0, then best sub I is equal to best of j plus 1, either max of this or itself. Basically, this is saying i's num sub i's what the parent is num sub j, meaning that it's the smaller number that can go into. Yeah. And then now at the very end, of course, we take the max of all the best answers, and that should be good if we didn't have the path reconstruction. I know that I mean, I didn't forget. I'm just doing some explanation, but we can run it just to see if that gives us. Okay, fine. I guess we have to. Yeah, I just wanted to see if that at least matches our expectations. Oh man, sometimes Python 2 syntax seeps in a little bit. Play to win. Yeah, so 2 and 4, that looks good. That feels good, even though of course we didn't do the path reconstruction. So this is dynamic programming. Longest path in the DAG, definitely practice this if you don't know. And then now we're going to do the path reconstruction part. And the way that you do it is by keeping track of this thing, right? Here we say it without tracking it, but we can actually track it. So parent is equal to -1 times n. And then here in this case, we go, okay, if best of j plus 1 is bigger than best, typo, then we set this thing, right? This part is the same as what we wrote. I'm just rewriting it. But now we can set the parents, as we said, parents of I is equal to j, right? That means that if you think about it in terms of these numbers, it means that there's a pointer from 8 to 4, and then 4 to 2, and so forth. It's a little bit, I mean, these examples are terrible to illustrating it, but if you have, say, I don't know, 1, 2, 3, 4, 8, 10, 8, 10, 12, for example, 12 will have a parent pointer to 4 because 12 mod 4 is 0. 10 would have a pointer to 2. 8 would have a pointer to 4 presumably, and 3 would have a pointer to 1, right? I say pointer in a very loose sense, in that that's what this thing I call it a pointer, but it's not a pointer in the regular sense, I guess. But it's like it keeps track of an index, which is the pointer of the array, which I don't know, right? And then now you can print this again, right? Just to kind of see what this situation is. And this should give you the previous one and -1 if there's no previous ones, right? So yeah, so 8 points at 4, as I said, and we could even add the thing that we said earlier. Oh, I deleted it. And you can kind of see it for yourself that it will always go for the best answer. Yeah. So for example, 20 goes to 20 actually goes to 4, which I guess makes sense because 4 is actually the longest path, even though 10 is the biggest number that mods 20. 4 is the one that leads to more numbers in the subset, right? So here we do path reconstruction. There are a couple of ways you can do this. You could do it recursively, or you could do it with a while loop. I'm going to do it with a I'm going to do it with a loop. Basically, now first of all, we have to get where the best index is, and that's what it sounds like. We have to get the best index. So yeah, let's just say best I is equal to say 0, and then for I in range of n, if best of I is greater than best of best I, then best I is equal to I. So then now we have the best index that contains this, and then now we do a path reconstruction looking backwards. And the way that we do this is by starting at, let's say we have answer is equal to or actually the best answer is equal to best I, because this is nums of best I. So we start at the number, and then we could, while best I is not equal to -1, and -1 is what we put as having no parents, and then while that is not true, we go best I is equal to parent of best I. Basically, we set the index to the parent, and then answer that append. I guess technically I should do it in this order, and also that means that I should remove this. And then once it gets to best I, it'll be good. This is actually reverse, kind of, how you want to phrase it. I mean, it's still a valid answer. It's just that it's in from large to small, which it's okay either way. But yeah, but as you can see, this looks good. So let's give it a submit. Wait, let me make sure that I do the. I feel like I've been messing up some cases. Like, I don't know. I mean, maybe that should be good. Okay, so let's give it a submit. Apparently I've solved this twice before, including once when I was in Croatia. I do remember vaguely about this because someone was asking me about it. Yeah, let me kind of take a quick look. I wonder how I did it last time. I think I did it differently last time. Nope, I did not. I actually did it the same way last time. What about the first time? Also did it the same way the first time. So okay. Whoops. Okay, so what is the complexity? Like I said, this is going to be n squared because of this loop, these two loops. So this is O of n squared. This, of course, will be adverse O of n and O of n. So this is going to be dominated by this for time. And for space, this is going to be O of n space for the two linear arrays and technically the sort, if you want to say that. And also the answer. So a lot of linear things, but just linear altogether. Yeah, that's pretty much all I have for this one. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. Let me know how you solved this. Let me know how you're doing. Hope you're staying good. Stay healthy to good mental health. Take care. Bye-bye.